Okay, guys, welcome to chapter 4. We're learning all about matrices and what we can do with them. I'm holding the book because I'm going to read you or remind you of a few things before we start doing the actual math. A matrix is a rectangular arrangement of numbers in rows and columns. If you look at this, rows are your horizontal, columns are your vertical. You read the dimension by rows and columns. So you're looking at rows times columns. For example, my first one has 3 rows. This one is 3 rows by only one column. There's only one row of numbers. This one right here, just the first one, would be a 2 rows, row, row, by how many columns? Well, I have 1, 2, and so forth. You can go on and build as big as matrices as you want. Okay, I mean, they just keep going and going and going. But you always read them rows by columns, never columns by rows. You have all kind of type of matrices. I'm on page 199 again. You have a row matrix, which is just made out of rows. There's just one row, many columns, but one row. You have what we call a column matrix, which means it has only one column. This would be a column matrix. This would be a column matrix. One column, many rows. We have a square matrix, which means the row and the columns number are equal. This is a 2 by 2. It could be a 3 by 3. It could be a whatever. We also have something that we call a zero matrix, which means everything inside that matrix is 0. 0, 0, 0, 0, 0, 0, okay? The main important rule that you need to know, or 2 important rules, is 2 matrices are equal if the numbers inside of them are equal. If you look on the bottom of 199, on A, you have 5, 0, negative 4 over 4, and 3 over 4. The other matrix is 5, 0, negative 1, and 0.75. If I take that negative 4 over 4, that becomes a negative 1, and 3 over 4 becomes a 0.75, which means each corresponding term, this one is to equal this one equals this one equals this one, and this one equals this one. If that happens, then those 2 matrices are equal, okay? The other thing you need to understand is you cannot add or subtract matrices unless they have the same number of rows and columns. Okay, if one of them has 3 rows and the other one has 2 rows, you can't add them up. They have to have the same number of rows and the same number of columns. Example 2 on page 200 says add or subtract the matrices if possible. Let's look at the first case. This is a 3 by 1, 3 rows times 1 column. This is a 3 by 1. They are identical, right? 3, 3, 1, 1. I can add them, and we said the way we add, we go 3 plus 1, 4. Negative 4 plus 0, negative 4. 7 plus 3, 10. Really, this is not hard math. I doubt you find this difficult. And we're done. We added it. Let's do a subtraction. First of all, let's see, is this possible or not? I'm going to turn this like this so you can actually see me when I talk to you. Is this possible or not? Well, this is a 2 rows by 2 columns. This is a 2 rows by 2 columns. Yes, we can. They have the same number of rows, same number of columns. We're going to minus now. It's just regular minus. 8 minus 2, 6. 3 minus 10. Minus becomes a plus. Minus 7. I gave you the answer. 3 minus 7. This becomes a plus. 3 plus 7 is 10. Let's move to the bottom. 4 minus 6, negative 2. 0 minus 1, positive 1. Why? Minus 1 is a positive 1. So we just go term by term, and we either add or subtract whatever I need to do. Let's look at the third one. This is a 2 by 2. This is a 2 by 1. It has 2 rows. This one has 2 columns, only 1 column. Not possible. We cannot add these 2 because they are not having the same measurements, okay? So this is how we add or subtract matrices. And the one thing we want to remember is you cannot add or subtract matrices unless they have the same number of rows and columns. That changes when it deals with multiplication. But right now, we're going to do multiplying a matrix by a scalar. What does that mean? Here it is. 3 times, a scalar is just a number, just sits out there on its own, and it's not in the matrix form. Negative 2, 0, 4, negative 2, 0, 4, and negative 7. Well, this is just as simple as you can think. We're just going to distribute the 3 everywhere, multiply it with each term, and get our answer. 3 times negative 2, negative 6, 3 times 0, 0, 3 times 4, 12, 3 times negative 7, negative 21. We're done. We have done the multiplication. Let's do the second example. Negative 2. And my matrix is 1, 0, negative 4. My second column is negative 2, 3, 5. But now they're adding something else to it, and they actually make you also add another matrix. Negative 4, 6, negative 2, and 5, negative 8, and 6. Okay, first things we're going to do every single time is do the scalar multiplication. It's just like in any math thing. Multiplication comes before addition. I don't have the space. You would rewrite this about the multiplication. I'm just going to modify this. Negative 2 times 1, negative 2. Negative 2 times negative 2 becomes a positive 4. This stays a 0. This becomes a negative 6. Negative 2 times negative 4 becomes a positive 8. Negative times 5, a negative 10. I'm going to erase this because I already multiplied it in. And now all I have to do is go ahead and add. Negative 2 plus negative 4, negative 6, 4 plus 5, 9, 0 plus 6, 6, negative 6 plus negative 8, negative 14, 8 plus negative 2, 6, negative 10 plus 6, negative 4, and that is the answer. That's in the book. So, when you have a multiplication by a scalar and then an addition, you do the multiplying first, then you add, and then you move on. Now, as we move on to example 4, which is we're solving a matrix equation, this is not very difficult at all. Let's look at this for just a second. We have a 2, a humongous parenthesis because we're doing what matrices? And my first matrix is 3x and a negative 1 and an 8 and a 5. Close it, and I think it's adding another matrix. And then I close this, and it's going to equal, believe it or not, another matrix. And this is a lot of writing for me, just so you know. 4, negative 2, 1, and y, or negative y? Negative y. And it's supposed to equal 26, 12, 0, and 8. And we're going to do this just like we would do any other thing. We have parentheses. That's first. So we're first going to do the addition. This becomes 2 times this matrix, which is 3x plus 4 is 3x plus 4, believe it or not. Negative 1 plus 1 becomes 0. 8 plus negative 2, 6. 5 minus y is literally 5 minus y. And all of this needs to equal 26, 0, 12, and 8. That we just copied. I don't have enough space, so you're going to have to work with me on this as I time this scalar over. 2 times 0, 0. 2 times 6 becomes 12. I have to distribute. 2 times 3x becomes 6x. 2 times 4 becomes 8. 2 times 5 is 10. 2 times negative y, negative 2y. This is now gone. And now we have to solve for x and y, which is really easy. Remember when we said 2 equal matrices? That means each of their terms equal each other, which means 6x plus 8 needs to equal 26, right? This needs to equal this, which means 6x equals 18, x equals 3, y 18, 26 minus 8, 18. And then look on the bottom, 10 minus 2y needs to equal 8, or negative 2y equals negative 2, y equals 1. So your x is 1 and your y is 3. How did we do this? As soon as we get here and we know it's an equality, we go, well, this one is the first row, first column needs to equal the first row, first column. The last row, last column needs to equal the last row, last column. It just becomes a basic equation. And then we solve them and we figure that one out, okay? Now, we have a word problem on the next page that we're going to have to do. And lordy, am I lazy doing it. But we're going to do it together, okay? It's giving you all kind of information. It's telling you use matrices to just organize the information. Here's what we know. We have this year, and we have next year. That's what we know for a fact. The next thing we know, we're talking about healthcare cares. We have 3 types of healthcare plans, and I'm going to be very lazy, And I'm going to write it. I need space, I think, based on those numbers. On a very small. Comprehensive. And that's what it stays for. The next one is HMO standard. HMO standard. And then you have HMO. That is plus, which is, I don't know, something. You get more health insurance. And now we get to know we have two different plans. And I need to put this a little bit higher. You can get this health insurance by individual, or you can get it as a family, right? Let me put this a little bit higher also. And a family. And now we just get to go, okay, well, for this year, how much is the comp? It's 694.33. How much is for the family? 1725.36. Okay, well, how much is the MO standard? 451.80. 80, and for the family, it is 1187.76. And then for the other one is 489.48. And then 1248.12. And then we move on to the next one. The next year, 683.81. I'm going to write them as fast as I can. I was going to skip this step, but it looks like we're going to have to do some stuff from for the example 5, 27. And then the last one is 1699.48. You know, you could really fast forward. You don't have to watch me do all this. 1217. And get to the point where I'm actually doing math and not writing stuff. 1273.08. And we organize this in matrix form, right? In matrix form. And I probably need to rewrite this to where they correspond. This is comp. This is HMO standard. This is HMO plus, right? Now we have taken a lot of information and we wrote it as a 3x2, right? 3 rows by the type of insurance and 2 columns by the type of insurance you get as a family, individual or family. You could have also did the other way. I could have put individual and family here and comp HMOS and HMOP over there, and we would have gotten a 2x3, 2 rows by 3 columns. Both ways are correct. So when you do homework, you do tests, however you organize it, it's the same to me, as long as you organize it correctly. And they both follow the same step, okay? On example 5 is coming from example 4, and it's telling us a company offers the healthcare plans in example 5 to its employees. The employee receives monthly paychecks from which the healthcare is deducted. Use the matrix in example 5 to write a matrix that shows the monthly charges in healthcare payments from this year to next year. So, first thing you want to know is by how much it increases from one year to another monthly. So, here's what I need to do. If I would name this matrix A and this matrix B, first of all, I need to go B minus A. Then I will know exactly how much I pay extra. But keep in mind, this is yearly, which means once I get this, I need to times this all by 1/12. Why? There's 12 months in a year, because I want to know what is by month. So this becomes 1/12 times. And Lord help us all, I'm going to copy from the book. It's going to be this minus this, which is negative 10.41. I was reading to make sure I'm doing this right. 11.30. Actually is, but I don't understand why they said it like that. Okay, so they named this B and they named the next year's A. That's why I was confused. Because I was like, this is not looking correctly. Why is this negative? This is Next year versus, which makes sense. You're going to have to subtract this from this to get what you get. Never mind. I am there now. Okay. 11.3, 9.79, and that is on individual plans. On the other one is negative 25.88, and then 29.69, and then 24.96. And when I do that timing by 1 over 12 to get exactly how much it will increase from one or decrease from one year to another, depending on what plan you're picking, it says that times 112, we get approximately negative 0.87 cents per plan. Well, I need the approximately here. It's going to be over here. Or it's, so this is a negative. It decreases if you stay with the what is it called? Comprehensive plan. It decreases on next year. You pay less. If you stay with HMO standard, you're going to pay 94 cents per month more. If you stay for the plus one, you're going to pay 82 cents more. Or if you go by family, if you go with the first plan, you get, your plan gets lower by $2.16. But if you go with the other one, you're going to pay $2.47 more, or $2.08 more. Really, the key on this would be to go, what's the difference of next year versus the first year? That's why they named it differently. That really confused me. And then you times it by 1 over 12 because you have 12 months in a year. You don't have a lot of homework like this. I try to stay away from it. But this is how it works. And I copied the numbers from there because I refuse to do computer work or calculator work right now. Happy homework.